Hello guys. So today we're going to talk about storage class and specifiers of C. As you all know that every variable in C programming has two different properties. That is, one is type and one is storage class. So here type refers to the data type of a variable and storage class determines the scope and lifetime of a variable. Storage class specifiers in C language, what it tells that to the compiler where to store a variable, how to store the variable, what is the initial value of the variable, and its lifetime of that particular variable. So here every variable in a program has memory associated with it. Memory requirement of a variable is different for every different variable. So in C, memory is allocated and released at different places. So here the definition of a storage class defines the scope and lifetime of a variable and functions within a C program. So the syntax is the storage specifier, the data type, and the variable name. So what does scope mean? Scope is nothing but a region or a part of a program in which variable is accessible. So the lifetime, it means the period of time during which the memory is associated with the variable. Next we are going to see the types of storage class specifiers in C. So there are 4 storage class specifiers available in C, that is auto, extern, static, and register. So let's discuss about auto storage class. Auto storage class is a default storage class for all the variables which are declared inside a function or even a block. So because it is a default storage class, keyword auto is rarely used while writing a program in C language. An auto variable can be only accessed within a block or a function which they have been declared and not outside them. This accessibility within a block or a function defines their scope. So as earlier, scope is nothing but a region or a part of a program in which a variable is accessible. Of course, these can be accessed within a nested block or within a parent block in which the auto variable was declared. However, they can be even accessed outside their scope using the concept of pointers. Pointers here are nothing but pointing to the very exact memory location where the variable resides. So what happens here, every time a variable is declared, they are assigned a garbage value by default. So this is a brief explanation on auto storage class. Auto storage class is a default storage class, a variable declared inside a function without any storage class specification is called a automatic variable. These automatic variables are created when a function is called and destroyed automatically when a function exists. See, this particular automatic creation and destruction is the scope. Scope tells us the region or a part of a program in which variable is accessible. Extent, that is the time period during which a memory is associated with a variable. So here automatic variables can also be called as local variables because they are local to a function. So by default they are assigned garbage value by the compiler. So what does this garbage value actually mean? Whenever any variable is declared, whether value is assigned or not, the variable resides on some space of memory. So if a value is initialized during variable declaration, then the bit values which are present in the memory location is replaced with the initialized value. Then what happens if it is not initializing any value? The memory location will have already a default value. This default value is called as garbage value. So let's type a program to find the garbage value of a particular variable. Open your code block. You're initializing two values here. Int a is equal to 5, int b See, now here you can see you've declared and initialized a, but you have just declared b, you have not initialized any value. So what will happen? A will be initialized with a binary number 5 and b will have a garbage value. I'll save it, run and show you. See here, it's giving you a random value of 8. So this is the scenario. What happens when you don't declare a? Suppose a you've not declared, just int a. Your a memory location will already have some certain value. So after declaring, what happens? Your binary of a is equal to 5. 5 in binary is written as 101. So, and others are replaced by 0. So value is replaced. This whole without declaring value is replaced by 5 after declaring it. So conclusion is that value which is present in an uninitialized variable is a garbage value. Garbage value, as the name it says, it is a useless value. Uninitialized value or unintended initialization results in a garbage value. When you run this program, you may get different values because garbage values are unpredictable. So this is the way you explicitly declare auto storage class, auto, the data type, and your variable name, auto int num. So here's an example, int mount or auto int month. Here the above example, it defines two variables within the same storage class. Auto can be used only within a function. So these two variables are local variables. So this is a brief explanation about automatic variable. Storage is memory. The scope is local or block scope. Lifetime is exists as long as the control remains in the block. So it destroyed once it is out of the block. Default initial value is the garbage value. So let's type a example for an auto variable. Save this, build it and run it. You need to get 3 to 1 as the output. I'll explain you how the program works now. So here in this program, compiler treats the 3i's as totally different variable because it is defined in 3 different blocks. So what happens is, once the control comes out of the innermost block, the variable I with value 3 is lost. So the I in the second printf refers to the value with 2. Similarly, when the control comes out of the innermost block, the third printf refers to the I with value 1. Hence, it is clear that the scope of I is local to the block in which it is defined. So here we are going to talk about external storage. External storage class is used to give a reference of a global variable which is visible to all the program files. So when you use extern, the variable cannot be initialized. So it points the variable name at a storage location that has been previously defined. So suppose when you have multiple files and you define a global variable or a global function which will be used in another files, then extern will be used in another file to provide the reference of the defined variable or a defined function. So extern is used to declare a global variable or a global function in another variable. The extern modifier is most commonly used when there are two or more files sharing the same global variable or global function. So here's a brief note on external storage classes. Variables of the storage classes are global variables. Global variables are declared outside the function and is accessible to all the functions in the program. So generally external storage classes are declared again in the function using the keyword extern. So in order to explicit declaration of a variable, we use the keyword extern. So let's type an example for external storage classes. Save it, build it and run it. So you're getting outputs num95, num95. Here the global variable is num, which is declared outside the function int num is equal to 95. So here in this main function, you're calling num, you're asking that to print, and a display function is externally declared. So that display function also prints the does a function which prints the value of num. So because it is declared and initialized externally, num will be same for both the values. So brief note on global variable. So storage is memory, scope of a global variable is global, lifetime exists as long as variable is running and retains value within the function. So default initial value of a global variable is 0. So next we are going to talk about static storage class. Here static storage class tells the compiler to keep a local variable in existence during the lifetime of a program instead of creating and destroying it each time it comes into and goes out of a scope. So therefore, making local variables static allows them to maintain their values between the function calls. So the static modifier may also be applied to global variables. When this is done, it causes the variable scope to be restricted to the file in which it is declared. So in C programming, when static is used on a class data member, it causes only one copy of that member to be shared to all other objects in its class. This is a brief note on static storage class. So a static storage class is declared by using the word static data type int I. The value of the static variable persists until the end of the program. Let's see an example for static storage class. Save it, build it and run it. You're getting 0 and 5. So why are you getting 0 and 5? Here what happens during the first call of the function, that is print C, the value of C is equal to 0. Then the value is increased. During the second call, variable C is not initialized to 0 again. It is because C is a static variable. So 5 is displayed on the screen. So here next we are going to talk about register storage class, which is used to define local variables that should be stored in a register instead of a RAM. This means that the variable has a maximum size which is equal to a register size, and these cannot have a unary operator applied to it because they don't have a memory location. The register should only be used for variables that require quick access to a counter. Counters are nothing but commonly used instructions. It should also be noted that defining registers does not mean that variable will be stored in a register. It means that it might be stored in a register depending on hardware and implementation restrictions. So here's a brief note on register storage classes. The register keyword is used to declare a register variable. Register variables were supposed to be faster than the local variable. Register variables are also local variables, but they are stored in register memory, whereas auto variables are stored in the CPU's main memory. So register variable will be accessed very faster than the normal variables because they are stored in register memory rather than in the main memory. Only limited variables can be stored in register because register size is very low. Now let's see an example for register storage classes. Open your code blocks. Save it, build it and run it. So enter the number 2, enter the second number 3. So sum of numbers is 5. Explain you the working of this program. So in this program we had declared two variables n1 and n2. These two variables are stored in the RAM. Another variable which was declared is stored as a register variable. These register variables are stored in the register of the microprocessor. Thus, memory access will be very faster than the other variables. So, suppose if we try to declare more register variables, then it can treat variables as auto storage variables as memory of microprocessor is fixed and limited. So the final conclusion of a register is register keyword is used to define local variables. Local variable are stored in register instead of RAM. Variable is stored in register, so the maximum size of variable is equal to the maximum size of register. Unary operator cannot be associated with it because it is not stored in RAM. These are generally faster access, and common use is counter. So this is a brief explanation about all the four storage classes and its description. Here auto, storage place is CPU. So the initial or default value is the garbage value. Scope is local. Life is only within the function. In extern, storage place is CPU memory. Initial value is 0. Scope is global. Life is till the end of the program. Static, storage place is CPU memory. Initial value is 0. Scope is local. Life is retains the value of a variable between different function calls. Register, storage place is register memory. Initial value is garbage value. Scope is local. Life is within the function only. So with this I end my video. Thanks for watching patiently. Please do subscribe. Thank you. Bye.